2022 Paper 2, Question 1. Question 1, the table shows some details on different types of students in the university. There are 22,714 students in the university in total. Fill in the three missing values. So they're easy enough. You're just totaling down and you're just totaling across. So just using addition and subtraction, find the values that make the totals add up correctly. One student is picked at random from the students at the university. O is the probability the student is 24 years or older. U be the event that the student is an undergraduate. Are the events independent? Justify your answer. If events are independent, then the product of the events must be equal to the probability of the events occurring at the same time. So probability of O multiplied with probability of U must be equal to probability of probability of O intersection U. Just make sure that's U, that's the event, not union. So we go with the probability of O of being 24 years or older. That's 8,576 students out of 22,714. So our probability is the following fraction. Next, the probability of U being an undergraduate. That's 15,707 students over 22,714. Finally, the probability of O intersection U being 24 and older and being an undergraduate. The people who are 24 and older and undergraduates are 2,922 out of 22,714. We need to check if these two values now are equal. We calculate both sides and we see that they are not equal. Hence our conclusion is they are not independent. Part B. 3 people are picked at random from a class. Find the probability that all 3 were born on the same day of a week. Assume the probability of being born on each day is the same. It's a common question in textbooks. There are 3 people. First of all, you get the probability that the first person is born on a day of the week. So the probability for the first person born on a day of the week is 7 out of 7. And you want the other person to be born on the same day. So and means multiply. So given that that's a specific day, the probability of the next person being born on that same day is 1 out of 7. And, meaning multiply, the third person, same thing. You want them on that one specific day, that's 1 out of 7, giving you a probability of 1 over 49. Part C, there are B boys and G girls in the class, where B and G are elements of the natural numbers. 3/5 of the students in the class are girls. 4 boys and 4 girls join the class. One student is then picked at random from the whole class. The probability this student is a girl is now 4 out of 7. Find the value of B, find the value of G. So the number of boys is B, number of girls is G, and the total number of people must be B plus G. So if now I want the probability of getting a girl, that must be G, the number of girls, over the total number of people, B plus G, but I already know that that's equal to 3/5. After more students have been added to the class, we know the number of boys is B plus 4, the number of girls is G plus 4, and the total number of people is B plus 4 plus G plus 4, which is B plus G plus 8. So now the probability of a girl is the number of girls, which is G plus 4, over the total of number of people, which is B plus G plus 8. We already know that's equal to 4/7. Now I'm just going to get rid of my fractions in both of these by cross-multiplying and turning them into 2 nice equations. Two equations, A and B, 2G minus 3B equals 0, 3G minus 4B equals 4, simultaneous equations to solve. Multiplying equation A by 4 and equation B by minus 3, we solve for G equals 12, and we sub back in for B. You answer get B is 8 and G is 12.